Good afternoon, everybody. Welcome to Science Access. Today we continue with our differentiation series. Today we'll be diving on the logarithmic differentiation. For this kind of differentiation, if you want to be acquainted with this differentiation, please go through our previous video. Our polynomial function, quotient function, and the product function, because we're going to use some of the laws in this one, like our indices, quotient, and product. Now, please, if you know that you are new to this channel, can you like and press the notification button so that you get more of our video whenever we upload them. Now, remember this one, if y equals u v w. Remember, this one is kind of different from our quotient and product, because after the y equals, there are three functions. Before, remember our product, we just have our uv. Our quotient, we have y equals to our u all over v. But this one, there are three functions there. So this is different. We are going to use this law during the course of our solving. We're going to use this law as well. So please pay close attention. I told you before, go through our previous video for better understanding. Thank you. And now, regarding this kind of question, we're going to take log of both sides. Taking log or natural log of both sides, we take the log of this one, the log of this side. Now, taking log of this one will lead us to log e y equals log e u v w. But from indices, log e u v w equals, we're going to use the law of indices for this one, equals log eu plus log e v plus log e w. You see? Therefore, log ey equals log eu plus log ev plus log ew. Now we cannot differentiate. Now differentiating this one. Remember that you take note that our y here is our function, our variable. Now differentiating y, how do you go about this? First of all, easy. Differentiate the function here, which is our y, as a variable. Will give us y, and we write what is differentiated. Y, right? Now give us 1 over y dy dx equals, the same thing is applicable here. We differentiate our function, which is our u, right? 1 all over what is differentiated times the differential form of u. This is the formula. Please pay close attention. Plus, the same thing is applicable here. Differentiate our v, which will give us y, 1 all over what is differentiated, the v, times the differential form of v, plus the same thing as well. Differentiate the function, which is our w1, all over what is differentiated times the differential form of our w. Now, if you see normal question they ask, they say find the y dx with this kind of equation. How do we find the y dx? Yes, very easy. We will eliminate y from this side, leaving behind the y dx. How do you go about this? You multiply y on both sides of the equation, leading to here. We make the y dx the solution of the formula by multiplying y throughout the equation, from the left, right of the equation to the right side of the equation. Very easy. Now, y, right? Y cancel y will give us 1 divided 1, give us 1. So 1 times the y dx will give us 1 dy dx equals the y as well, right? Now, everything here, we'll repeat it here. So this is our formula we'll be using at the cost of full solving. Now, we're going to solve series of examples for better understanding. Now, example number 1, y equals x to the power of 4 exponential to the power of 3x tan x. Find the y dx. The question here, they say you should find the y dx, the variation of y with respect to x. Now with the question, y equals u v w. Now, where our u is x, the first function here, x is to the power of 4. Now, the u dx, the variation of u with respect to x, equals 4x to the power of 3. Now, we take the next function as our v, which is exponential to the power of 3x. V equals exponential to the power of 3x. Now, the v dx equals 3 exponential 3x to the power of 3x. Now, when our last function, which is our tan x, as our W. Equals tan x. Now the W over the x respect to x equals sec square x. Now with the general formula, y equals u v w bracket open 1 all over u times du dx plus 1 all over v times dv dx plus 1 all over w times dw dx. This is the formula we'll be using for this question. Now, remember they said find dy dx. So now, obeying them, dy dx equals our, what is our u? Our u is our x to the power of 4. Our v, which is the one what we have here, our v is exponential, while our w is our tan x. Now, open our bracket now. 1 all over u. Remember, 1 all over u. Our u here is x to the fourth power, right? X to the power of 4 times the differential form of our du dx. Our du dx is 4x to the power of 3 times 4x to the power of 3. You see? Plus, going to our v now. Our v is 1 all over v. Our v here is exponential. Our v here is exponential. That's to the power of 3x. See, exponential to the power of 3x times our dv dx. Our dv dx is 3 exponential 3x. 3 exponential to the power of 3x plus now 1 all over w. Our w here is our tan. Remember? Our tan, right? So now 1 over tan times the differential form of our w, which is our dw dx, our sec square x. Sec square x is our w. So now the y dx equals, repeats our x to the fourth power exponential to the power of 3x, our tan x, bracket open. Now, yeah, 4 we multiply 4x to the third power with this y. 4 times 1, 4x to the third power times 1. It gives us 4x to the power of 3 all over 4. You see, plus this one times 1, it gives us this one all over exponential 3x plus this sec square x times 1 give us sec square x all over tan. This is how we arrive at this place. Now, dy dx equals, repeats this one as well, x to the fourth power exponential to the power of 3x tan x, bracket open. Now, 3 into 4 give us 1, right? Remove 3 from 4 give us 1, right? Now, 4 all over x. You see, very easy. Plus now 3 exponential to the power of 3x all over exponential to the power of 3x. This one will cross out each other, leaving behind 3. That's how we got our 3 here. Plus sec square x all over tan x still remains the same. This is our final answer for this question here. This is our final answer for this one. Now, moving to question number 2. Question number 2. If y equals x raised to the third power tan x all over x sin x. You see, this one is kind of different because we have a division sign, right? All over the function. 2 function all over another function. So we use another formula. Another formula is applicable to this one. Now, mind you, they say find the y dx. Find the y dx. Now, we take u as our x raised to the third power, our v as our tan, and our w as our sine. This is how we have it here. Our u is our x raised to the third power. Now, du dx. Differentiation of u with respect to x equals 3x raised to the second power, raised to the power of 2. Now, our v as our tan. Differentiating this v, the v dx equals, differentiating tan will give us sec square x. Now, our w will be our sine, w equals to sine. Differentiating sine with respect to x, the w dx equals, differentiating sine will give us cos x. Now, dy dx equals u v all over w. Remember that this one is our y, according to the formula I gave earlier. So bracket open 1 all over u times the differential form of u du dx plus 1 all over v times the differential form of v dv dx minus, because it's all over, 1 all over w times the differential form of w dw dx, bracket close. This is the formula we'll be using. Now, let's into the question. dy dx equals, now where is our u? Our u is x raised to the third power. Our v is tan x all over where our w is sin x, bracket open. 1, remember 1 all over u. So our u here will be x raised to the third power times the differential form of u, which is the du dx 3x raised to the second power. We have the right. Now plus 1 all over v. Where is our v? Our v is tan x all over tan x times the differential form of v, which is our dv dx, equals sec square x, sec square x minus 1 all over w. Our w here is our sin x, sin x, we have it here. Now the differential form of the w dx is cos x, bracket close. Now dy dx equals x raised to the third power tan x all over sin x, bracket open. Now this 3x raised to the second power multiplied by 1 will give us 3x raised to the second power time plus sec square x times 1 give us sec square x all over tan minus cos x times 1 will give us cos x all over sine. Now dy dx equals x raised to the third power tan x all over sine, bracket open, 3x raised to the second power all over 3. And now just remove 2 from 3, which will give us 1. That's how we got this one. 3 all over x plus sec square x and x, give us, repeat it because there's no specific figure for that one. It still remains the same. Minus cos x all over sin x, it gives us cot x. It's our answer. Cos s all over sin s give us cot s. This is our answer for this, but no specific value for this one. This one, you see, remove 2 from 3, give us 1. This is now our final answer for this question. Remember, the first formula I used was different from this one. That one was all plus throughout. This one, remember, in log 2, this one, two function multiplying themselves together is plus sign. Like this one, uv in log is plus. Why something is all over another, u all over v is minus. You understand? Remember that law, very, very applicable in this one. Question number 3. Y equals exponential raised to the third 3x all over x to the power of 2 sine x. Now the question here is, find the y dx. Y equals u all over vw. We took the exponential raised to the power of 3x as our u. Now differentiating u with respect to x, du dx equals, differentiating this one, you have 3 exponential raised to the power of 3x. Now moving to v, which is our x raised to the second power, v equals x raised to the second power, dv dx equals 2x. Now moving to w, the sin x, w equals sin x, dw dx equals cos s. That is it for that. Now, using the general formula for this question, dy dx equals u over vw, bracket open, 1 over u times the differential form of u du dx minus the division sign is a negative sign in logarithm, that's why the sign is here. Now 1 over v times the differential form of v, which is the dv dx, plus, see, now when in logarithm, when two functions are multiplying themselves, it is plus, it turns positive. So since they are multiplying themselves, it is positive. That's how we have our plus here. The v and the w, the v and the w, they are adding themselves together. A log, it is called we use the plus sign instead of the multiplication sign. Now 1 over the w, which is our sign here, times the differential form of the w dx. Okay, now the y dx equals our u. Where's our u? Our u is exponential raised to the power of 3x all over our v, and w is x raised to the power of 2 and sans x respectively. Now bracket open, we have 1 all over our u, which is our exponential raised to the power of 3x, times the differential form of our u, which is the 3 exponential raised to the power of 3x, minus 1 all over v. Our v here is x raised to the second power, times the differential form of v, which is the 2x, right? Yes, the plus sign remains the same, and y, the w here, our signs, bring it here. What is the differential form of w respect to x is our cos, have it here as well. Now remember they say find the y dx. Now the y dx equals, repeats this one here, exponential, 3x all over x raised to the second power sinus h, bracket open. Now 3 exponential raised to the power 3x times 1 will give you 3, the same 3 exponential raised to the power 3x all over exponential 3x, minus now 2x times 1 will give you 2x all over x raised to the second power, plus this cos s times 1 will give you cos s all over sinus s. Finally, the y dx equals, repeat the same. Yeah, bring this one down. Exponential raised to the power of 3s all over x raised to the second power sinus s. Bracket close. Now you see, this one tends to cancel out each other because they're the same, leaving us with 3 minus, see, 2x all over x squared. Remove this x from this x squared, leaving us with x and 2. So 2 over x. So our result here. The positive side remains the same. Plus now our cos x all over sin s will give us cot s. Remember our cos all over sin cos s sin s will give us cot s. So the same rule applies here. It's very, whether it's cos or sine, it will still give us our cot. Theorem number 4. Why our y is exponential raised to the power of 4x all over s raised to the third power cos 2s. Now here our y is u all over v w. Now we take our u as our exponential. This is one I have here. Exponential is to the power of 4x. Now the differential form of u with respect to x, the u dx equals 4 exponential raised to the power of 4x. Then we move to our v here. We are using the formula to solve the question. Now our v here is our x raised to the third power. So v equals x raised to the third power. Derivative v with respect to x, the v dx equals the derivative dx raised to the third power, give us 3x raised to the second power. Now the last portion here, which is the w will be our cos 2x. So w, our cos 2x, as we said earlier, the differential form of the w is the w dx equals 2 sinus 2x. 2 sinus 2s is the differential form of the cos 2s. Now using the general formula, which says the y dx equals u over vw, bracket open 1 over u times the differential form of u, which is the u dx, minus the u dx minus 1 all over v times the differential form of v, which is the dv dx. Now and plus 1 all over w times the differential form of w, the w dx. Now I remember I told you earlier that when a function is divided on another function, it is negative sign logarithm. While if when a function is then multiplying with another function, joining with another function, the logarithm, we use the positive sign. Now, I hope that is noted. Dy dx equals, now our u, as we said earlier, we take exponential, our exponential as our u, we take our s as our v, and our cos as our w. The same rules apply here. Bracket open, our y all over. Our u here is x raised to the power of 4x times, I told you before, the differential form of u, the u dx here. Our du dx is 4 exponential raised to the power of 4x minus 1 times our v. Remember we took x raised to the third power as our v, x raised to the third power times the differential form of v, which is the dv dx. Our dv dx is 3x raised to the second power. You see? 3x raised to the second power. Now, 1 all over w. Our w, we took our cos 2x as our w, and while the differential form of the w dx is 2 sines 2x. Now remember, they say find the y dx. The y dx equals exponential raised to the power of 4x all over x raised to the third power cos 2x. Bracket open. Now, the 4 exponential raised to the power of 4x multiplied by 1 will give you the same value, 4 exponential raised to the power of 4x all over exponential raised to the power of 4x minus 3x raised to the second power times 1, which give us the same value, 3x to the power of 2 all over x raised to the third power plus 1 all over cos 2x. Now, see the dot here, this means multiplication sign, so that means this one will be multiplying the 1. Now, 2 sines 2x times 1 will give us 2 sines 2x all over cos 2x. Finally, the y dx equals, repeat the same value here, exponential raised to the power of 4x all over x raised to the third power cos 2x. Bracket open. Now here, since we are arriving at our final answer, this one, we cancel out this one, which should give us 4 minus 3x raised to the second power all over x raised to the third power. So subtracting 2 from 3, leave out with 1. So 3 over 1 plus positive sign here plus 2 sines 2x all over cos plus 2 sines 2x all over cos 2x. Now, remember that sine x all over cos x will give us tan x. Please don't forget sin x dividing all over cos x will give us tan x, while cos x all over sin x according to trig will give us cot s. So the same rule applies to this. Whatever that is cot or cos, or that is sine or sines. Sine 2x all over cos 2x will give us tan 2x. These two comes here as well. So this is the final answer for this question. We arrive at our answer at this point. This is our final answer. Now, moving to question number 5. Now, natural log, finding natural log, bracket double sine 2x. Find the y dx. Wow. Natural log, bracket open, sine 2x. Find the y dx. Now, the y dx equals, remember our log rule. This is the function, right? Now, we differentiate the function. Differentiate the function sine 2x will give us 2 cos 2x over what's differentiated sine 2x, right? Now, I told you before, cos x all over sine x will give us cot x. Now, you see, cos and sine are the same. So the final answer, this is not your final answer. You cannot leave your answer like this. Something can still be done. So this one, cos x, 2x all over sine 2x will give us cot 2x. These two will be added. So this is the final answer. This is the answer to this question. So this is the answer to the question. If you have any question regarding this topic or the question so far we've solved, please kindly drop it at the comment section. We promise to lay it into consideration and to give a response as soon as possible. So thank you and God bless you.